I'm so honored to be here. Um, as he introduced me, and I came from George Washington University in DC. I am educational measurement person, and then I happen to developing a assessment system, which is computer adaptive formative assessment system with two other colleagues last year. Actually, we're working on few years for this system, but inside of, in the process of the development, and we use a lot of Google API. So today, the major purpose of this presentation is actually, and explaining and showing how those Google API has been used for this particular new development. Again, I'm working on the Cafa, which is computer adaptive formative assessment engine, and this engine had a many application and client system, and and inside of engine and many client system, and I've been using a lot of Google application. So probably it's good to start with what is computer adaptive formative system, which is Cafa. Computer adaptive formative assessment system is combination of computer adaptive and formative assessment, which is very simple formula because this is combination of both of them. Probably it's very nice to explain this Cafa system from motivation first. Why we have to develop this Cafa system. First of all, in theory, there's some evolutional assessment theory. 1900 to 1950, we call it the classical test theory era. And a lot of mean, mode, median, percentile, ranking, t-value, and that kind of stuff has been developed this area. And since then, next 30 years, and so-called item response theory, like probably most of our standardized tests, SAT, GRE, and computer adaptive testing system is rely on this IRT model. And 1980 to 2010, diagnostic assessment. Right now in San Francisco, there's a huge measurement conference going on. There's 100 people gathering around, and then they are talking about this IRT and diagnostic modeling right now in San Francisco, and this weekend especially. As a scholar, I was very interested in what is next generation of this diagnostic model, which is from today to 20 years and 30 years, and what will be the future of the assessment. And then many people talk about future of assessment likely to be a formative assessment. So and then this is actually one of the motivation why I need to think about the formative assessment model. And there's another motivation too, which is practice. The reason is nowadays we have so much emphasis on assessment, but the emphasis on assessment and those put much weight on the assessment, not necessarily helping students out. For example, teaching to test, studying for test, not necessarily teachers are teaching for student learning, but teachers are teaching for test, and the students are learning for test. To maximizing score, that's why they are learning. So that kind of side effect is there, and also, there's a huge dropping out and huge giving up. For example, math exam, they just gave up. They're not studying anymore at some point. And also triaging student in the classroom practice, and then still we still struggling on the low achievement, even those assessments. So why we spend a lot of money and a lot of energy and a lot of effort on the assessment, why this kind of vicious cycle is still there? Because we spend more money and energy and cost to assessment, still practice doesn't help. And at some point, our practice getting worse because of that assessment issue. The main reason I identified the why assessments and the practice is not getting along well is, first of all, we had too much emphasis on summative assessment. Summative assessment, the major purpose of summative assessment is monitoring and ranking students. And then summative assessment purpose is gathering information for decision maker. basically. That's actually major purpose of summative assessment. But however, there's another side of assessment, which is formative assessment. Formative assessment is major purpose of formative assessment is assisting and helping students. And especially we are gathering information from students to helping students. So that is actually fundamental differences between formative and summative assessment. And formative assessment is educational 101, and anyone take basic education course and assessment course, and there's this definition has been around like 100 years. So, but one of the key element of formative assessment is modifying teaching and learning activity and providing feedback, and then details about contents and performance, and related to contents and performance. So providing this kind of feedback and modifying and teaching and learning activity is very, very cool, but there's a reason why this is not practical yet. Because most of practice in our classroom and accountability system, we heavily rely on summative assessment. So I studied and why this kind of cool formative assessment is not so much popular yet, and that there are three major reasons I able to identify. The first one is the standard-based, largely determined what is taught in classroom. Because teacher need to teach is based on summative criterion. So standard has been set up for majorly focus on summative sense or summative sense fashion. And then second of all, the lack of the connection between classroom approach to teaching and national monitoring system. In short, like accountability system. If you are good in terms of a formative assessment teacher, not necessarily you are good in summative assessment, some good teacher in summative assessment sense. Because national monitoring system is so heavily rely on summative sense, so not necessarily, teacher want to be a formative assessment, formative teacher, but they couldn't be there. The reason is they will be evaluated and monitored, and that they will be guided by summative, this accountability system. And third of all, the lack of resources for the classroom practice. As we see the definition of formative assessment, they have to tailor the feedback, instant feedback. They have to modify their curriculum and instruction based on information. But teachers do not have time to providing their individual and tailored feedback in the classroom, because there's absolutely no time and the lack of resources of this beautiful formative assessment in practice. That's the reason why. Okay, and then if we wanted to make this formative assessment as practical, what kind of things should be done? First of all, and then it should be, the formative assessment should be strictly based on standard. Second of all, and we have to let computer or network to help teacher to providing that kind of feedback and instruction, and we have to help them, how to actually teacher can make this formative assessment becomes a practical. And the third one is we have to have a clear accountability system, which is, are you a good teacher in terms of formative assessment? And then we have to build in this accountability system into the new development. And the last one, it should be formative, which is treatment-centered. Treatment-centered is that this system need to focus on how to help students, how to effectively help students. So program need to generate information immediately and effectively and practically, and how to help students. So what is it? And then I start to define this big picture of, okay, if I want to, and a new system, which is computer adaptive formative assessment system, need to include those kind of elements. Standard-based should be formative, of course, and computer-assisted or computer adaptive, and need to be psychometrically valid, which is my major, which is educational researcher, and including accountability system too. So last year, I had a beta version with the other colleagues, and the colleagues are Dr. Sunny Kim. He is math contents expert, and also Dr. Kyung-il Yoon. he is computer science people. So me as assessment and educational management people, and the three of us, we decided to make this computer adaptive formative assessment system last year. And then any education context, we need to have some kind of application. And for application, we need to have a so-called subject. So we can shopping around what kind of subject will be the best fit for this system, and then we decide to tackle mathematics first. So there's an English version, we just thinking about it, but right now, this computer adaptive formative assessment as a subject matter, that we decide to math, because math is very, very easy to tackle as a first trier. All right, so far we talk about motivational computer adaptive formative assessment, and we will getting into component of the computer adaptive formative assessment. There's a computer adaptive formative assessment. The Cafa system had several layers, and I want to probably, this structure layer is best way to understand what's going on and what, how this computer adaptive formative assessment has been built up. First of all, very inside of this system, there's auto item generation component. We will talk about in detail later. And outside, there's a cognitive knowledge map feature in there. And also there's a computer adaptive feature. And then also next layer, we putting into lots of applications, client, server system. And then the very end, and to meet the actual practitioners and the outside world people, we are doing globalization layer as a very, very outfit. First of all, let me introduce auto item generation. Auto item generation system is, if you had one pattern, and the one pattern generating very, very many instances. Because right now we are working with the math, instead of 1 plus 2 equal to 3, we make a pattern as A plus B equal to C, and then we randomize A, randomize B, and then we will get a randomized C. So if we, based on that one particular pattern, we are able to generate many, many instances. So computer adaptive and the Cafa system gear up this AIG, auto item generation module, at the most essential part of the system. Why? Why you gear up this AIG as the most essential part of computer system? The reason is, first of all, if you want to do the formative assessment, and you need to provide adequate contents coverage. Because to cover entire contents area, you need to have a huge amount of mathematic items. So, because we can't just in the hand, it takes so long, and then there's a huge demand of the building up the huge item bank. That's first the reason why we treat this auto item generation as core part of this Cafa system. Second of all, cognitive knowledge map approach, which is we break it down in the mathematic skills in the very, very fine details, and then we adapt common core state standard into our system. There's 1,000 skills, and each skill requires, to measure each skill, which is 1,000 skills, require many items. So eventually, item bank should be humongous. So that's the reason why, that's the second reason to measure all those, many details, mathematic skills, we have to gear up this auto item generation module. And item exposure control too, because we should able to expose our item for the security reason. Because we can use the same item over and over and over, but if we have one pattern, still we have a security issue for each specific pattern, but at least they need to solve that particular pattern. And then last one is, this computer adaptive formative Cafa system is engine can have many applications. For example, G-learning, game learning environment, or eWorkBook environment. Many other type of application require this kind of many different type of item generation. So that's the reason why we also, this is the last reason why we gear up this auto item generation as core part. All right. Can you go to the example of this AIG module. This is one of the example of auto item generation. This is like in this, the one of the auto item generation challenge is there's a huge amount of image generation inside of there, because if we want a high quality of math item, there's a chart there and mathematical equation there. So on the fly, if we have to generating those images, right? And and that's the reason why the first hurdle we have to get through is how we taking care of those images. And then, one of my colleagues, which is Dr. Yoon, and one day and come back, hey, Jaehwa, how about we are using Google API, which is Image. Google Image API providing those on-the-fly image generation system, and if we take advantage of those Google API, and then we can, generating all those math equation, especially it's for free. So I didn't know this kind of API exists by then, but he find out that this Google API. So now we able to generating all those features and the math equations on the fly, and whenever we want, and we're using this API, and we move up to our auto item generation system quality to the next level. Most of auto item generation system, conventional auto item generation system, do not fully taking care of those math equation. But we have a square root there, division there, matrix there. But Google API, let us to open that entire new world. So we especially thanks for that this API uses. And also, this is Korean, another math item. I know some of you are familiar, some of you are not familiar, because a lot of math item can be translated into different languages. Because this is math item, so it's relatively easy to translate. And then when translate, and then we are using Google Translation API, and then it accelerates a huge amount of time to translate the other languages. And also there's beyond those math equation, and a lot of math item require chart. So we also use Google API chart to enabling this auto item generation inside of engine. So this chart and this proportion and can be dynamically changed according to certain certain situation. So based on this Google Translation module, and then we can translate one English item to Korean, Japanese, and Chinese, and all other languages, and very easily. All right. Next component of Cafa system is cognitive knowledge map system. Cognitive knowledge map system, before moving on to the cognitive knowledge map system, let me introduce this common core state standard. Cafa system is strictly rely on this common core state standard. 2012, government, coordinated by NGA, this common core standard has been published. Still, this is prototype beta version, but in short, in common core state standard mathematics, and they break it down the entire K-12 mathematics contents into approximately 600 skills. So we take these 600 skills, and we also benchmarking Korea and Japan, and we extending those kind of K-12. K-12 education system is slightly different from each country, but their mathematics skill itself is pretty much, similar. But the only difference is, for example, Korea had a, calculus inside of K-12 system. So we amended those 400 calculus related to skill set, and we got approximately 1,000 skill set. Very, very, very unique, and very, very, very operationalizable mathematical skill set. We able to get it. We call it as Common Core Global Standard. Because the reason why I call it as a Common Core Global Standard, and these standards taking care of the most of K-12 system in the world. All right. based on get those common core standard, I'm treating this K1 to K sub K as standard. For example, we have 1,000 columns, each column representing, each K representing each mathematical skills, and I representing each item. So we start building up item bank using auto item generation module from to cover to K to K, K to K,000, for example. So first item is, as an example, is only connected to K1, which is this particular first item is to measure specifically, and it's only require K1 as as a skill. And then also, for example, last item, it require K1, K2, K3. This item representing to solve this particular last item, we need to know someone need to know K1 and K2 and K3 skills. So this is relationship between each item, which is module for us, auto item generation module, to entire the skills and standard. So in psychometric term, we call it as this matrix as a Q matrix, because this governs relationship between instrument and the thing we're supposed to measure, which is skills. And then above and beyond, those standards were there, but those standards are just approximately follow the approximate sequence of each grade. Okay, 5th grade there's a domain A, for example, geometry, domain B, and domain C, and the 6th grade, and we also had a domain A, B, C. But we know, and then likely students supposedly know the 5th grade knowledge to move on to the 6th grade, but not necessarily, because they have a lot more detailed relationship, which is prerequisite relationship between those standards. So we start building up the next part, which is start to connect, because those each grade standard in more details. And the expert actually connect this, providing this prototype of this connection, and then we collect the data, and based on the data, we hypothesizing this relationship and empirically validating those relationships too. So there's some expert validation and empirical validation on this knowledge map. In other words, the process, what I did it in the bottom part of here is basically we building up the relationship between each K and K. Which K had a prerequisite of the other K? Because when you solve some particular math problem, at some point, you have to know that the other mathematical skills to solve one certain thing. Or the other way around, and the other, and then to solve a particular mathematical skill item, you don't have to know the other thing. So that's the reason why the 1,000, this matrix illustrating relationship between 1,000 skills and 1,000 skill. I call it as a Cafa matrix, which is relationship between among those Ks. So element of these things getting bigger and getting bigger at some point is computationally extremely challenging business, how to estimate those things, because it's easy. Contents expert providing this map itself is very challenging and require huge amount of data to validating this relationship too. But inside of our engine, we keep doing this business because this map is very, very crucial part of entire system with to providing adequate feedback to students. Anyway, for example, and then next, the purpose of this system is finding out a particular type, a particular set of skill set works as a bottleneck. Because now we are able to identify students and the given information, hey, you need to study this. That's the reason why you stuck on the 80%. Not anymore, okay, you're 80%, pass, fail. Now we're able to diagnosing students' skill set, and we're able to provide feedback and pinpoint feedback based on their diagnosis, which is treatment, I call it. So the particular skill set, mathematical skill set, they struggled and that they need to master in urgent matter, I call it as Epicenter. Epicenter is just another name of particular skill set they supposed to study as a very, very early and urgently. Okay, this is another way of illustrating this epicenter. For example, first grade to the seventh grade, and then there's each grade that there had a standard, and the height representing their mastery level of each standard. So in this system, we try to find out what particular type of skill set need to be improved to maximizing entire surface can be drifted up. Because every standard is connected to each other. It's not independent. So it really, really depends on which one need to move up to maximizing entire surface move up. So this is fundamental algorithm idea to defining epicenter. So epicenter is the best, best position they need to study, and if they master that particular standard, and then they will easily move on to the next learning process. Inside of this model, and for example, between subject model is given time framework, and then for example, each standard skill can be measured by several items. In psychometric term, we call this item theoretical IRT model. And once we measured those standard mastery level, relationship between standard, which is latent variable, can be estimated by structure equation modeling, which is another psychometric term. And this relationship, because most of students are nested within teacher, and the teachers are nested within school, so we also adapting multi-level modeling, hierarchical linear modeling approach. And then those estimation should be done with the Bayesian approach. The reason is we have a few small information to cover a lot of unknown parameters. Technically, there's a huge amount of too many unknown parameters compared to our known information. So we need to rely on strong informative prior in Bayesian framework. So this is actually psychometric term. Again, we call it as a latent variable modeling, and social behavior science people doing it. And as I mentioned to you, we have like 100 people in San Francisco right now in ARA conference doing all those latent variable modeling techniques. So I belong to one of those, psychometrician. Another challenge of this particular system is because we provide feedback and we have to monitor student progress over time. And each skill set mastery level, which is mastery level 0 to 1, which is bounded. And we also think about this kind of nonlinear growth modeling. Because over time, how those standards either aggregated or each standard progress. So sometimes a lot of, for example, this is one student's over 3 skills progress. And each skill, that particular student, 3 skills are starting from the fairly bottom line, but each skill get a different asymptote in upper asymptote. The other example is they have a different type of lower asymptote they started, but they saturated into the different type of lower asymptote differently and upper asymptote differently. And the last example is they started with a very different type of starting line, but eventually they were able to master all different skills. So this kind of variation and over time change can be estimated by these 4 primary logistic regression logistic growth modeling. And there's some papers and references I'm working on it. So especially 2 days ago, I proposed a particular methodological approach how to evaluating this kind of particular Cafa system in logistic growth modeling framework. All right. Cognitive map. So far, I talked about cognitive map, and then let me move on to the formative assessment model again. Formative assessment model is, so far, our assessment model is fairly focus on how they, the major purpose of the traditional assessment model is how to accurately measure where and how student is. But treatment-centered is nowadays, people are sick of those kind of, knowing. The reason is to know is not enough. We have to help them, not just understanding where they are, and there's a strong demand how to help students. So that's the reason why we move our paradigm to treatment-centered approach. Treatment-centered approach is the model estimating, the assessment model is estimating what kind of things students need to study now, instead of where they are, what's their percentile rank, or the accurate relative location, because model try to estimate what they need to study. So model generate what they need to study to help student immediately. So, there's a first generation and third generation. I call it the fourth generation model is formative assessment model, which is given data, there's a person parameter and item parameter and diagnosis parameter, and on the top of this diagnosis parameter, we also estimating this treatment parameter. So let me explain what kind of formative assessment model role inside of this Cafa system. Cafa system basically estimating treatment. Treatment can be unfolded into epicenter list, which is number of standard they need to study with priority. Priority is very important because not just we point out the 3 epicenter, this skill set need to study earlier and the next and the others. So we also provide this priority of the epicenter and also exposure weight too. So how many time you have to spend on this particular skill set and how many time you spend on particular skill set and later, and how many times, how much time you need to spend on the later of the standard. So then this kind of treatment, and there's folded into 3 different directions too. First of all, student feedback, or treatment to students, and treatment to parents, and treatment to teacher. So this system generating three different type of feedback or treatment. We call it a study guide for students. We call it parental guide for parents, and we call it the instructional guide to teacher. So this system generating these 3 different type of feedback or information to maximizing student learning. This is just a diagram and how those things are worked out, and then every student providing information to Cafa engine, and this engine generating feedback to teacher, parents, and students. And the student feedback or student treatment can decompose into like a book information, which book they need to study, and which study video they need to learn or watch, and what kind of practice problem they need to solve, and what kind of game they need to do it. So we provide those detailed information, study information to students and and teacher and parents too. All those informations are tailored feedback and tailored information. Computer generated this kind of tailored feedback, and teacher and parents and students able to taking advantage of those kind of computer generated and tailored feedback. Let me get into more specifically for this study book information. Study book information is the first facet of the student feedback. Basically, we provide the textbook information to strengthening each student epicenter, because we know that we have a complete known epicenter list, and this system identified what kind of each student, what kind of epicenter they need to study, and we are mapping this epicenter to book information. So sometimes we system actually building up the database and what kind of book they need to study for each epicenter, or we are using Google Book API or product search, and then we are searching up the books and what kind of book is best book for or book information for students to strengthening this particular textbook information angle. The other angle is study video, because we have, for example, 1,000 epicenter, and the one student's got like a 3 epicenter list. So each epicenter they have a specific mathematical knowledge, and also we are using YouTube API. What kind of video is best fit for that particular student's epicenters? Right now, I know, there's 1,000 videos there, and it's not fully matching this epicenter. The great news is every year, an appropriate video has been developed by other people. So instead of we developing our own video, we are taking advantage of the other people developing, and we are mapping those other people, YouTube video to our contents. So over here, I think there's dramatic change on the especially last 2 years, 3 years, because a lot of people are generating those specific standard related to study video. So students able to taking advantage of those video treatment through this YouTube API. Again, we also provide practice problem, which is strengthening their epicenters. Because Cafa AIG module, as I also explained, and the AIG module had a lot of Google API on there. So based on that AIG, we generate a lot of practice problem, almost the infinite number of practice problem to students until they able to master a particular set of skills. Okay, applications. There's several applications there. Cafa engine is, the reason why I call it as engine is there's so many applications are available. Number one is e-learning. We're able to provide the learning opportunity to students based on this, Cafa engine, right? And then second of all, we also apply this to the testing service, like a formal education, web-based computer adaptive testing service. This, full item bank, which is geared up to AIG, and diagnostic and treatment process can be integrated into regular testing service. And also, this Cafa engine can be applicable to eWorkBook or workbook on demand or tailored workbook type of thing, electronic workbook. Not anymore, this is just beyond PDF and electronic workbook, and that we can make their own individual workbook based on their progress. So on the fly, we're able to generating those computer-generated workbook tailored to particular student skill set portfolio. And also, we also apply this Cafa engine to G-learning environment. A lot of, right now, I'm working on the Penta Games company to setting up protocol from this Cafa engine to game application, because game application require a lot of different type of, AIG. They really appreciate AIG module because they don't have to keep up those huge size of item bank inside of game. They just communicating our server to they able to getting out those math item, and then they're using storytelling game and pure math game or action game, and they are or quiz game, and they're applying those math item into the game context. And on e-learning application, last year we launched a emastest.com, which provide a daily tailored math worksheet, entire K-12 standard base. So it covers entire K-12 standard, and especially for free to all students in the world. So a lot of students are taking advantage of this emastest.com, but and thanks to emastest.com, I also want to thanks to Google, because as I explained to you, the reason why we able to provide this math free worksheet to entire student is we were able to use Google API, image, charts, and Google search APIs inside of this engine. Again, this K-12 standard-based, more learning type of application can be extendable by helping of those Google translation module for example, right now it's all math items are in English, but expanded to Korean, Japan, and Spanish, and over here and over here. But relatively, the cost of translating those math items and using Google Translation API is a lot cheaper than math item creation. So relatively cheaper. So it's easy to expanding to, it's easy to serve global service in different cultural or language application in future. We had another particular service too, which is in Korean service. This service is slightly different from K-12 service in emstest.com. We call it ksat.emstest.com. This is particular for the SAT. This is Korean SAT prep test. So this is not anymore K-12 entire direction, but we only focus on high school, and we separating entire high school standard, the 400 standard, and we do the more summative practice type of test. So the orientation is slightly different, and we will develop this similar type of application with just SAT and ACT or all other standardized test prep service is available. Is it possible actually? And another application we are working on it is Workbook on Demand and eWorkBook service. Based on this assessment server, through assessment server, and if students getting or people getting into assessment server, and then they take some assessment, and based on that assessment information, and eWorkBook server generating their tailored workbook for them. So they can shoot that PDF file, the only the electronic PDF file to customer, or they can send, or simultaneously the electronic file can be sent to some public, printing company, and that printing company printed and shipping to other, like for example Kinko. We email to that information, to customer information to the Kinko, and Kinko print that out and the shipping to the customer. So still not anymore exactly same workbook they will get it. Nowadays they able to get at least a math workbook, individualized math workbook whenever they want. And we're working on this part right now. We don't have particular application example yet. And another one is we developing a lot of mobile device. So beyond just the web-based, and then everything we developing this mobile. For example, this Android, Android system, and we're developing very different type of client application. So client application and gathering, for example, at school client providing activities and information at school, and then there all those mathematic activities and learning activity information is gathered into the server system, and also that kind of same information can be gathered in after school and at home too. So whether student playing in the game, whether student doing a classroom activity at the classroom with teacher, whether they're doing a home activity, after school activity, and all information communicating with the server. So we have so-called ubiquitous assessment system, and those kind of to enable that kind of ubiquitous assessment system, this Android system is one of the best platform that we are developing our client and server application too. Okay, closing remarks, and I exactly got a 45 minutes. So there's a lot of educational technology emphasis in education world. We call it e-learning and mobile learning, smart learning, and ubiquitous learning. I just introduced ubiquitous assessment system and G-learning too. But the reality is nowadays, because everything is connected and network-based, and people, I realize, and I have to learn a lot about what kind of Google API I can be. We can use for the enable this educational technology. Whether Google developer or Google, when you guys providing those APIs, it can be used for this educational technology. But I think that this is a great example from my side to introduce this kind of example to my colleague to assessment and educational technology people. And also I want to mention this kind of example to you guys because, we, especially thanks to you guys, API to enable this educational technology, especially mstest.com, a lot of students are taking advantage of the free education service because of the Google APIs. Okay, thank you so much for your time. Have any questions? Okay.
How do you measure mastery in a particular epicenter?
Yeah. Particular epicenter, we have to break it down several pieces. Particular epicenter mastery level, we call it as item response theory model because epicenter is in the end one particular skill set, right? Skill, but indicated by several items. So we built up a lot of items, and for example, we generating a workbook, and they did a workbook, and the workbook provide information, they get right, and they get wrong. So based on those workbook activity, and for example, they do the game, and they get it right on that math game, and they did it wrong on the math game, and based collection of those information actually, and using so-called IRT model, we estimate those latent trait, which is skill, which is unknown actually, but we had information about they got right and wrong on those instruments. But basically their skill is latent variable. We estimating those latent variable through IRT model. But given IRT model and given those skill set, what is epicenter is which one they need to study, they mastered urgently or priority. That is actually epicenter. So there's some psychometric term, but IRT model, but it's not that much hard. If you email me, and then I will shoot you more details of IRT. But there's a standardized psychometric model, which is item response theory model, which is exactly same way our GRE score, SAT score is graded and scored scale. Yes.
I'm curious, once you determine the student needs to learn X amount of skills, how do they actually accomplish that? And I'm thinking other aspect as in motivation, engagement, how much they practice versus not practice. Is there some study that you have in that direction? Or?
That's actually a very challenging part because we provide information, hey, you guys need to study this one based on this book and this game and this workbook and this study video. And we cannot fully measure on all those, for example, we call it that's a treatment. Like we went to the doctor and the doctor did some diagnosis and doctor give me a pill and which is treatment. But fidelity issue is, did you take that pill and tonight or not? It's completely next level of information, right? And then through this ubiquitous assessment system, we try to measure every little piece. Okay, do they open up the study video or not? And they watch that study video or not? Measured by when they did end, right? And that's the best information because we don't know. We can't measure their brain activity directly. And they did it or not on practice problem is very easy to measure because they need to submit and that they got submitted answers, and we get to know the way how they did it or not. So fidelity, we call it as a fidelity of intervention or fidelity of treatment issue, but that's also good. But because of this kind of ubiquitous assessment environment, and then there's a lot of room to gathering all those activities. Now all of a sudden becomes too many information, and then so-called large data analysis skills need to be done. But right now, again, it's estimation process, and then how to use that kind of auxiliary information to also measure those fidelity of those intervention. That's actually future study issue. Not future. It's currently we highly working on the how to cooperating that kind of thing, which is result or fidelity of treatment. Right now, we heavily rely on providing treatment, but absolutely, we have to gather that information. Yes, sir.
First of all, let me say I really enjoyed the talk.
Thank you so much.
Great piece of work. But if you allow me to be the devil's advocate, at the beginning of the talk you were saying that there is this loop where students are studying for a test and they just learn the specific skills for this test and we don't achieve much this way. But here with your system that identify these epicenters and encourage students to bridge these gaps, aren't we doing the exact same things? Of course, instead of being for a test, it's for reaching the common standards. But at the end, we are still trying to make every student fit in the same mold, right?
I can't say the last year description. We try to make all students in the end the same same pool. Okay. I'm not sure that I understand your question correctly, but again, this, for example, our purpose of. Let me explain this your question by this epicenter. My answer is yes or no, and likely to no. The reason is the main purpose of this system is we want to help students in pinpoint information we provide, efficiently help students and move on to the next step. So we are not necessarily all students get an 80% of mastery level, right? Or we are not necessarily concerned about all students getting into a certain level. And I think I completely understand different students have a different portfolio. But be able to unfolding, for example, you got an 80% on mastery level on average, and you got an 80% mastery level on average, but they have a completely different skill set portfolio. But finding epicenter is you want to move on to the next step, but you stuck on for example, you had you don't know the parenthesis rule. That's the reason why you keep getting wrong on items required the knowledge of the parenthesis rule, right? So we try to find out that pinpoint information, try to resolve in epicenter. But how you actually, what is your beautiful picture of entire skill set portfolio? Yeah, eventually everyone got a perfect mastery on the entire skill set. That's good. But we are not expecting all students to do it. They have a different skill set. Some students are very good at geometry. That's okay. Very good at inside of geometry. Some students are very good at a particular type of geometry. But and the company and employer and other people want to know that one. Instead of SAT score and 800, they want more details on what's going on over there. So in the portfolio. So we are not making all students in the same fit or a certain. But if we want to apply this system into, for example, policy relevant cut point 80%, that's okay. Whenever we want to do the 80% traditional summative type of cut point, yes, we can do it. But this system provides a lot more information than traditional 80%, 90% A or B, pass or fail type of thing. Again, we can use that system for that matter, traditional matter. But major purpose of this one is instead of decision making, we want to help students to providing what they need to study. So main purpose of this assessment is not anymore ranking or decision making only. We can do it, but the more fundamental reason why we are doing is how to effectively help students instantly.
The K matrix you showed?
Yeah, Cafa matrix.
Each column was a particular skill set, or a skill, I guess. And
yeah.
Do those correspond one-to-one with epicenters?
Yes, exactly. Well, Cafa is another name is skill set, and epicenter is particular skill set. One particular student need to be studied very, urgently. So epicenter is individually a particular skill set for students they need to study early or urgently.
You have 1,000 skills,
Exactly.
then you have 1,000,000.
Exactly.
So are those filled in by experts, or do you just determine the algorithms?
Good question. So I think I briefly explained that part, and then the back is the accuracy of feedback, accuracy of finding epicenter strictly depends on the validity of this Kappa matrix. So first of all, contents expert provide this relationship as a hypothesis and gathering data, and we tested that hypothesis and system generating, and then signal, hey, could you check up this relationship because data doesn't support this relationship? And then some relationship data strongly endorsing particular relationship. Otherwise, and the different contents expert had a different opinion about this, relationship among those K. But that's the reason why emstest.com, another reason why we open up emstest.com for free is the free data is gathered by every day. So those data actually, tuning into this Kappa matrix to accurately, building up this Kappa matrix. It takes for a while, and then it's not fully automated because we have to download the data, and using statistical software, we have to estimate hypothesis test, for example, using IRT and SCM matter, and then we have to communicate with that information. We have to communicate contents expert, and contents expert to revise that map again, and then provide again another information. So it's not fully automated yet, but eventually it's nice to fully automate it. But up to so far, number of things to be estimated, because look at this. This is relationship between K, 1,000 times 1,000, and element is too much. And estimating all those relationships simultaneously is, I know there's a lot of heuristic algorithm able to do it, but also require humongous amount of data, empirical data, to represent, behaving that relationship. So it takes for a while. But we're working on it. Right now we are more primitive way. Download data, statistical software doing it, getting in. It takes every month and every other month we download data and estimating those relationships. Yes, good question. And Kappa matrix is key point of the accuracy of diagnosis. Yes.
What's your vision for how Cafa system will integrate into the classroom? Will it be done something that you do at home, you come to class and the teacher will be provided with the assessment, or how would that work?
Yeah. Right now, emstest.com is just self. Whatever, there's not structured public education system. So a lot of students just doing by themselves with their parents. But we are developing some more mobile application. So using, Nexus, for example, Nexus, and the teacher and student can use in classroom. But those activity and those items generated by server, and then Nexus is one of device. For example, phone and those mobile devices just gateway terminal to communicating with server. So whether we did it activity in classroom and whether we did it activity at home as a workbook, whether we did it activity in by phone and game, all those informations are gathered into and communicating with server. So we actively working on this, developing that kind of multi scenario, different scenario. I organize it at school, after school, at home application using different type of app device. Because one website sitting there cannot cover everything. So we have to actively divide those different occasion and different purpose of applications to communicate this server, assessment server, which is Kappa assessment server. Any other question? Yes, sir.
Do you believe that one metric fits all students, or do you believe that multiple metrics should be used for each individual student?
Yeah. That's also a very good question. It's arguable. Kappa matrix I estimate this way, and expert provide prototype and data tested it, but I have to rely on the theory. Okay, there's a fundamental global structures there. God gave us how to learn, how to build up our mathematical knowledge from what path to counting, to K standard, to beautiful application of integration into high school level. But again, some people had a different route, but I believe the God had a formal, like a common route, which is pathway to build up their mathematical knowledge, or very popular way. How about that? Because data generated that system, because very popular way to achieve their building up, accumulating their mathematical skills up to the next moment. Yes, absolutely. Each individual had their different pathway. But right now, a statistical model is like a kind of aggregating those information and provide more like a likely, information or aggregated information. So yes, and then we are tackling to that issue by aggregating student information.
What are your next steps? How long before I can have a personal Aristotle tutor meeting on topics?
Okay, one of the great criticism or suggestion for this system is always, hey, Jaehwa, this is not a tutoring system. I want to say, yes, this is not a tutoring system. But right now, I don't want to compete with human tutoring system. But I want to provide this system to, when tutor teach, tutor can use this information. For example, like a teacher account. If teacher know my students are struggling in what kind of trouble spot, which is epicenter. Oh, you did this kind of activity last night, and that activity provide me information about what you are struggling on that particular skill set. And I'm designing this system to providing that information to teacher instead of computer actually taking care of everything to them, because that's actually my ambition. I never envisioned this entire system completely automate it and becomes a like a cyber tutor. No. Personally, no. Yeah. But instead, I'm making this system to very, very easy to use, ready to use, and pinpoint to use for other people, teachers, student, parents, to use this information to helping students efficiently. Yeah. Any other question? Okay, thank you so much for your time. I really appreciate it. Thank you.